Right, let's check the Doppler effect and the Diffusion question. Right, I say a traffic official is stationary. When you say stationary, the velocity equals to 0. Now, a traffic official, of course, that should be a listener on the side of a road where the speed limit is set 200 kilometers per hour. He hears a hooter of a car that is traveling at a constant velocity on this road. The hooter emits sound waves of frequency 433.64 hertz. What does it mean? So this is the frequency of sound. They are saying he hears the hooter of a car traveling at a constant velocity of this. The hooter emits. Now, once the hooter emits a sound wave of frequency, so this will be the sound, the frequency of the sound. The wavelength of the sound detected by the traffic official is 0, so now what is this one? Saying the wavelength detected by the sound, the wavelength of the sound detected by the traffic official. So what is this? This is the wavelength of the listener. That is because they're saying the wavelength of the sound detected by the traffic. So meaning the traffic hears this wavelength. So this means that is the wavelength of the listener. Now the speed of the sound is 340 meters per second. That is the Doppler effect in words. So right, they're saying state and the Doppler effect in words. Now this can be, it is a change in the, it is a change in the observed frequency of a sound wave when the sound source is moving relative to the listener. Right. Number 2 is calculate the frequency of the waves detected by the traffic official. Now they want the frequency. Remember the formula here saying the frequency equals to C over lambda, or the wavelength. Then in other words, they're saying the frequency of the listener, because detected by the traffic official. Traffic official is a listener. Roaring le mo equivalent frequency a listener, because this is the wavelength equal ke ke the listener, motho o re just sound. And then so the wavelength by the field is 0.72 meters, and then what is left we need to know the value of C. Let's check the value of C on the data sheet. That is the speed of sound in a vacuum. Our question paper here is not having formula sheet. The information sheet is missing on this question paper, so it means we'll have a problem of the answer sheet, so or the formula sheet. So there is no formula sheet. Okay. Oh, or rather change this, the speed of sound, and put it V, because here we're not in a vacuum, we are just experiencing this on the air. So this should be our 340, as they said, the speed of the sound. And then now we'll need to have our calculator. Let's take out our calculator and check. So we're going to have 340 divided by 0, 7, sorry for that, divided by 0, 72. So now the frequency that was hit by this calculator is a problem. So it's 340 over 0, 72. So this 472, 2 recurrings, so that will be hertz. So that is the frequency of the listener, or the frequency that is heard by the listener when the car is approaching the traffic official. Is the car traveling towards or away from the traffic official? Give a reason for the answer. So obviously is traveling towards. Why towards? Because when the car is producing this sound, the car is producing this sound of this frequency, which is 43364. But when the listener hear more than that, it means the car is approaching the person. The sound. So that's why I say it's towards. So the reason is that can say here's more frequency, here's higher frequency, here's higher frequency. That's why we're saying if it's moving away to here a lower frequency. Now perform calculation to determine whether the car is exceeding the speed limit. Remember, the speed limit is set to 100 kilometers per hour. And our calculations are done in meters per second. So let's see what we have. Number one, for us to calculate that, we need to write a formula. So a general formula of saying the frequency of the listener equals to V. Of course, we can copy that, saying plus minus the V of the listener over the velocity of the sound plus minus the velocity of the source multiplied by the frequency of the source. Right, let's see what we have. We have the frequency of the sound. Of the source, we have the frequency of the listener, and then we have the speed of the sound. And then what we have what is that we have? Oh, we have a traffic officer that is stationary. We have the velocity of the listener. So it means what do we have here? We're going to have, so that we don't get confused, so we simply have the frequency of the listener is how much? It's this one, 472,22 equals to the velocity of the sound is 340. So now, to avoid confusion, we know that this is the velocity of the listener is 0. So we're not going to write anything there. So we'll deal with this part. Now, there is 340 for the velocity of the sound. Now, we want the velocity of the source. Now, is it plus or minus now? Now, because the frequency, we're taking this frequency. What is it? Okay, 4 is multiplied by 4, 3,64. I mean, well, this frequency, if we take this one that he heard by the listener, it means we're taking this 340 multiplied by this number, we are dividing by a smaller number. So if you divide a smaller number, then we're going to have a bigger number as the output, because answer this one is from these multiplications. So that more will be minus, so that we can get a bigger answer here. So after doing that, we can have 340 minus the value of the sound source equals to 340 multiplied by 433.64 all over, I mean, Rawi from 472,22, that is algebra. So we can do the cross multiplication. This one multiply this one will come because here will be 1 multiplied by that, then you divide, then you can work through that. So arenally I mean the velocity. So we can have this negative velocity of the source equals to, then we're going to punch this one and then subtract 340. 340 to move in. So let's take our calculator. So roll 340 multiply by 4 3.64 divided by 472.22. Then 340 equal to minus 340. Then this is what we get. Now we multiply throughout by negative, and then our final answer should be 27.78 meters per second. Now the question was, is it this exceeding the speed limit? Now because of like meters per second, so Sonja converted this speed limit to meters per second. Let's convert that. The speed limit, so it means the limit equals to, now we're going to say 100 times kilo, so on kilo here, this kilo, so multiply by 1000, then the initial line meters divide by, then because this pay say divide by the hours, we're going to say 60, then remove the hours, and then multiply by 60 from the hours, then 20 minutes, then what is left is seconds. So now you can press calculator. Let's just press the calculator without wasting time. Say 100 multiply by 1000 and then divide by 60 by 60. So our answer here is 27.78. So it's saying now our speed limit equals to is the same as 27.777, that is 78 meters per second. Therefore, the speed are equal. So we're going to conclude that it is not exceeding the speed limit. It is not exceeding the speed limit. If the car travels at a lower constant speed, how will this affect the frequency detected by the traffic? Will be greater than, lower than, same as, but we're saying it's moving at a lower constant velocity. Now lower means we're going to subtract a smaller number here. So if you subtract a smaller number, it means now the value or smaller than that. So if we divide by a bigger number compared to this one, because r minus j 27,7 ra batla ra bo r minus 26,7 this number e ka mo fase denominator e a gola a e sa fokotse kudu e fokotse ya nnyane, so go tshwana le e gola. So this it means it must say less than. The answer should be less than, because now we're dividing by a bigger number. So that's what we have for this question.